Alright, our next problem reads, using phase diagram, explain how you'd prepare in a basic kitchen a water sample at its triple point. Alright, so first thing we're going to need is a phase diagram, and I have that right here. And then I'm also going to use this water bottle filled about halfway with water as a description of our kitchen sample of water. So right now I've just filled up a water bottle about halfway with water, and I haven't done anything else to it. So right now this phase diagram doesn't actually apply to this situation because we've got air still inside the bottle. It's not just water, and therefore this phase diagram of water does not apply. So what we're going to need to do is remove the air from this container. So there are a couple ways to do that. Some might say you might want to get some sort of vacuum, suck out the air, or maybe pour it into a smaller container or fill this container all the way up so that there's only liquid water in here. But what I think we should do is heat it up. Because right now we've got both air and a little bit of water vapor inside this top part of our container. And the partial pressure of the air plus the partial pressure of the water currently equals the pressure of the atmosphere around me. So right now the pressure of the vapor is less than the pressure of the atmosphere. And if we heat this up, temperature will increase and therefore pressure will increase. And as the pressure increases, it will reach the temperature of the atmosphere. It will reach the pressure of the atmosphere around me, So as we heat this up, the partial pressure of the water vapor will equal the pressure of the atmosphere around me. And the temperature at which this happens is called the boiling point. This is where more water vapor will begin to form. You can see this by bubbles forming within the liquid, and the vapor pressure reaches the pressure of the outside atmosphere. So we put this on heat and we let it boil. We let it boil for a few minutes, and as it boils, more water vapor will form and it will push the air out of our container. So it's been boiling for a little bit, so we're going to put the cap on top. And then we're going to remove the container from the heat. If we don't do that, temperature and pressure will continue to increase and the bottle may explode, which we don't want. So we've removed it from the heat. So now we've got liquid water and water vapor in our container and nothing else. So now this phase diagram will apply to our situation. So as I said, we're going to have some liquid water and some vapor water at the same time. This means that we're going to lie along this line on our curve. So we'll say we're lying around here somewhere. We've got both vapor water and liquid water. We're like right here on that point. So our goal is to get down here to the triple point. Now the triple point is where we've got liquid water, vapor water, and solid water all at the same time. So right now we've got 2 of the 3. To get the third, we're going to need to cool this down. In the kitchen, an easy way to do that would be to stick it in the freezer. So we stick this in the freezer for a few minutes, and we pull it out, and maybe some ice has started to form. So we've got some formation of ice. We've got some liquid water above it, and then we've got vapor water up here. Therefore, we have reached the triple point.